Hello dear students, welcome to this session. In this session, we shall be discussing demultiplexing of address data bus of 8085 using a particular chip. We call it as a latch 74373. Now, let us consider what is the meaning of multiplexing and then what is the meaning of demultiplexing. Uh, we have studied pin diagram of microprocessor 8085 and also we have studied its feature. Microprocessor 8085 has 16-bit address bus. Out of that 16 lines, A8 to A15, these 8 lines are pure address bus, and D0 to AD7, these are, again we call this as a low order address bus, but these 8 lines are multiplexed. Multiplex means time sharing. These 8 lines are used for giving the address, as well as these same 8 lines are used for data transmission, giving the data or receiving the data. Okay, the actually demultiplexing means these 16 lines are to be expanded into two separate bus, a pure separate address bus A0 to A15 and separate data bus. So this is other words expansion of 18 lines to 24 lines also. All right. Now why we need this demultiplexing? The reason is that microprocessor 8085 gives out address on these total 16 lines for memory reading or for memory writing. The 8 line, high order 8 line holds the address for 3T period. It holds, so address is there, remains there for 3T duration, whereas low order address 8 lines remains on these lines only for 1T duration. 1T कालावधीसाठीच फक्त इथे ॲड्रेस उपलब्ध असेल आणि या 8 लाईनवर 3T या कालावधीसाठी मी साधारणपणे 1 मायक्रोसेकंड आणि हे फक्त 0.3 मायक्रोसेकंड. ओके, बट we want this 16 lines address that should carry the address, and that address should remain there for full 1 microsecond, meaning every memory chip requires full 16-bit address for 3T duration, but here it remains only for 1T duration, and therefore we must use some other device that hold this address, because we want to relieve these 8 lines for data transmission. म्हणजे या 8 लाईन सुरुवातीला ॲड्रेस देण्यासाठी वापरायच्या आहेत आणि नंतरच्या 2T कालावधीसाठी डेटा देण्या घेण्यासाठी वापरायचा आहे. डेटा बस म्हणून त्याला वापरायचं आहे, म्हणून ॲड्रेस बस म्हणून त्याला मुक्त करायचं आहे. मुक्त करायचं म्हणजे आलेला ॲड्रेस कोणीतरी धरून ठेवायला पाहिजे. ते धरून ठेवणारं डिव्हाइस म्हणजे आहे लॅच 74373. So actually this latch is, I say 74373. It is a 8-bit latch. Latch means to hold. धरून ठेवणाराला latch म्हणतात. Okay, so it has 8 D type flip-flops. You know flip-flops, it has a D input, Q output. I am showing only input and output here, and it has a clock input also to trigger the flip-flop. So we have such a 8 D type flip-flops. The clock inputs are connected together, and that provides us a G common control to which ALE pin of microprocessor is connected. ALE stands for address latch enable, and to this latch we connect AD0 address data line, AD0 to AD7, and for output we get the separate address line A0 to A7. So idea is that when memory read or memory write operation is there, microprocessor gives full 16-bit address here, 8-bit 8-bit. At the same time this ELE goes high. So when this gate becomes 1, these 8 bits are gets locked, latched, and they are made available here, so that these 8 bits and these 8 bits now separately available on these 16 lines for complete 3T duration. So memory chips will get complete 16-bit address. And look at that, as these levels are hold here, these are made free for data transmission. So these lines are separately connected to data bus. So this is a system data bus and this is a system address bus, and this is what we call it as a demultiplexing of address data bus. Okay, let us consider one important 16-bit register of microprocessor 8085. This is, we have studied internal architecture of 8085 microprocessor, and there we have seen a stack pointer, that is a 16-bit register. Now before going to stack pointer, let us consider what is the stack. Stack is actually reserved portion of memory, RAM, where contents of CPU register pairs can be stored temporarily. 8085 has 16-bit, that is register pair BC, register pair DE in the diagram, register pair HL, BC, DE. These register pairs contents can be stored temporarily to the stack. Now it is called stack because 8085 stores register like stacking of plates. What is stack? Stack in Marathi we can call it as a dhig, a gatta, thappi. So see that this is stack and it is operated in the RAM and it has to be initialized in some part of the RAM. Okay, see that these red boxes indicates the RAM locations, and for the sampling I am giving you some address CC53 hex, CC54 hex, and so on. So this is a you can call this as a stack. When I store something here, the first register, रजिस्टर किंवा नोटबुकचा स्टॅक कसा राहील, आपण जर ठेवायचं असेल कपाटामध्ये तर कसं ठेवतं, पहिलं रजिस्टर इथे ठेवलं, त्याच्यावर हे रजिस्टर ठेवलं, त्याच्यावर हे ठेवलं, त्याच्यावर दुसरं रजिस्टर, त्याच्यावर असं रजिस्टर, असं रजिस्टर, असं रजिस्टर, तर हा काय तयार झाला, स्टॅक, राईट. सो इट इज स्टोर्ड केप्ट इन प्रॉपर ऑर्डर. आणि मग आपल्याला हे रजिस्टर हवं असेल तर पद्धत अशी की उशिरा ठेवलेलं अगोदर काढायचं. सो रिट्रीव, सो स्टोरिंग द रजिस्टर, storing the information and retrieving the information, and the idea is that it is operated in the manner of LIFO manner, last in first out. ह्या गठ्ठ्यामध्ये जे उशिरा ठेवणार आहे त्याला अगोदर बाहेर काढायचं आहे, last in first out, right? This is the stack. I repeat, stack is the portion of RAM kept reserved for storing register pair contents to memory temporarily, right? Now let us come to the stack pointer. Stack pointer is the 16-bit register which hold 16-bit address of stack top. ह्या स्टॅक टॉप आपण म्हणजे आय मीन स्टॅक जसं ऑपरेट करतो त्याचं टॉप सर्वात शेवट वरचं जे लोकेशन आहे शेवटी जे ऑपरेट करतो त्याला काय म्हणायचं, टॉप म्हणायचं आहे. आणि ह्या टॉपचा जो ॲड्रेस आहे तो कोण धरून ठेवणार? स्टॅक पॉइंटर. सो स्टॅक पॉइंटर ऑलवेज होल्ड्स 16-bit ॲड्रेस ऑफ स्टॅक टॉप. स्टॅक वेगळा, स्टॅक पॉइंटर वेगळा. ओके. So there are two instructions which are used for placing the register pair data to the stack, and that is called pushing the register pair. So when this push instruction is executed, the 16-bit register pair is pushed, stored to the stack, and retrieving the information from the stack to back to original register pair is called the popping. ठेवलेले 16-bit इन्फॉर्मेशन पुन्हा त्या रजिस्टरमध्ये आणणं, रजिस्टर पेअरमध्ये आणणं, त्याला म्हणायचं पॉपिंग. सो पॉप इज यूज टू रिट्रीव्ह द इन्फॉर्मेशन. स्टॅककडून ती माहिती इकडे परत घेणे. सो पुशिंग द इन्फॉर्मेशन अँड पॉपिंग द इन्फॉर्मेशन. पुश रजिस्टर पेअर, दॅट मीन्स इफ आय यूज से push B. Pushing the P means register pair BC. त्याच्यामध्ये C हा गृहीत धरायचा असतो, फक्त हाय ऑर्डर रजिस्टरचं नाव वापरायचं. सो पुश बी इन्स्ट्रक्शन, दॅट मीन्स कंटेंट्स ऑफ रजिस्टर पेअर BC आर pushed to the stack. Suppose that I have initialized the stack at CC59. This is the stack top now. And when BC pair contain, BC are the CPU registers. So first B is contents of register B are transferred to the stack, and then contents of register pair C are pushed to stack. And now see that earlier the stack top, this up to this हा स्टॅक इथपर्यंत भरलेला होता, परंतु आता त्यामध्ये 2 रजिस्टर ॲड केलेले आहेत, वर टाकले, म्हणून आता टॉप कुठं झाला? हां. सो SP which was pointing this particular location CC59 hex, now after pushing it will point CC57. That is the pushing operation. Then if you want to push another register, say for example D, push D. In this case, now stack top is this. First the contents of D register will be pushed, and then E register will be pushed. See that the location of RAM is always 8-bit, and we are storing the 16-bit. Therefore, to store 16-bit memory, 16-bit register pair contents, we need 2 locations. Now D is pushed, E is pushed, and therefore now top is now this, and therefore SP will point. So this is function of stack pointer. What it is saying? Information is fed up to this level, and this is the top of this stack. Now this is the pushing the information, pushing the register pair to the stack. The reverse of that, परत घ्यायचं असेल तर त्यासाठी कोणती इन्स्ट्रक्शन आहे? पॉप. सो लास्ट first we have pushed BC and then push D. Now I am popping DE first, pop D. So first of all, now SP is at this position, it is pointing, this is the top. So E will be retrieved, D will be retrieved, and then SP will indicate this. ही माहिती घेतल्यानंतर आता हे 2 काढून घेतलं म्हणजे टॉप काय झाला? हा झाला. हे काम कोण करतं? स्टॅक पॉइंटर करतं, राईट. आणि मग नंतर कुणाला पॉप करावं लागेल? पॉप बी. जे उशिरा ठेवलं होतं, लेट इन डी आपण लेट टाकलं होतं, तर ते पहिले घ्यायचं, फर्स्ट आउट, राईट. अँड देन पॉप बी, देन सी विल बी रिट्रीव्ड, बी विल बी रिट्रीव्ड, अँड वन्स अगेन SP विल पॉइंट दिस टॉप. तो अशा प्रकारे इन्फॉर्मेशन स्टॅकला ठेवता येते क्रमाने आणि इन्फॉर्मेशन क्रमाने घेता येते. तर हा झाला स्टॅक. स्टॅक इज अ स्पेशल पार्ट ऑफ रॅम केप्ट रिझर्व फॉर storing the 16-bit contents of register pairs of 8085. Stack pointer helps in managing this stack, and how it helps? It always holds the address of stack top, and the 2 instructions which are used for storing and retrieving, that is push and pop. When the 16-bit data is pushed to the stack pointer gets decremented by 2, याची 2ने व्हॅल्यू कमी होते. पुन्हा पुश केलं की 2ने कमी होते. पण पॉप केल्यानंतर काय होतं, स्टॅक पॉइंटरचे मध्ये असलेला जे ॲड्रेस आहे तो 2ने वाढत जातो. सो this is the purpose of stack pointer. Then the question might be occurring to your mind that why we need stack, why we want to store a 16-bit registers of 8085 temporary to the stack. The reason is that we have very limited number of registers in microprocessor. We have just very few, B, C, D, E, H, L, then accumulator. These are the accessible register available, and the same registers have to be used by different programs also. So therefore, if some data is there in this register at some point of executionच्या विशिष्ट वेळेला याच्यामध्ये विशिष्ट डेटा असू शकतो, and suppose that these registers are to be used for some other task, then the content of this register must be saved to the stack temporarily, then use this register for some other purpose by some other program, and after finishing that job, the content which were saved to the stack must be retrieved back retrospective. I mean, जसे होते तसे जिथल्या तेथे असं परत कंटेंट परत आणण्यासाठी. So same registers can be used for different programs, and these are very useful in subroutines. Okay, so let us stop here, and I think this unit is almost completed. Bye.